Welcome to Data Science with EJD. Since we are now talking about association rule learning under unsupervised learning under machine learning, um the next video this video is about market basket analysis, like I promised when I did the other video. Don't forget, uh we have this broad field of data science, and under it we find machine learning. Under machine learning we have supervised, unsupervised, and reinforcement learning. We've taken machine supervised learning, which involves classification and regression. Then we moved on to unsupervised learning, which we are currently dealing with, and that involves that involves clustering, and then dimensionality reduction, and now association rule learning. So after this, I would most likely look at reinforcement learning if possible. Okay. So question is, what is market basket analysis? Now, for association rule learning, we've seen Apriori algorithm, which is like the foundation for even market basket analysis. So this is the second video under association rule learning, and after this, we'll be looking at the I think frequent path growth, which is FP growth algorithm. So that'll be after this one. So here, what is market basket analysis? Market basket analysis, or MBA, is a data mining technique in association rule learning used to uncover associations or co-occurrences between items in large transactional data sets. It's the classic example of association rule mining. The goal is to find patterns like people who buy bread and butter often also buy milk, So typical business question will be, what products are frequently purchased together? So that's what you want to find out, especially if you have a business and you sell different kinds of products. So the applications, you can apply it in cross-selling and product bundling, and optimizing store layouts. Since if you know that people who buy bread also buy butter and milk and all that, you want to put them in the same area of your store. Then it's also good for personalized recommendations. So the problem setup is such that you have a transactional data set. Each row is a transaction, which is a kind of shopping basket, listing the items bought together. I mean, just like what we saw before, right? You have one: bread, milk, bread, diaper, beer, eggs, milk, diaper, beer, coke, milk, bread. I mean, bread, milk, diaper, beer, bread, milk, diaper, coke. Talking about the five transactions. So like three different customers come, and they buy these things according to their transactions, like that. So as you're, at the checkout counter, those are the things you have. So it means that if you have a supermarket and you want to create your own transaction ID, of course, and this is that everything is digitalized, right? You can just check the receipts. So if you want to have your own data in this situation for association rule learning, you can just check your receipt from the first to the last and list all the items they bought, and then you can do this analysis to see the items that people most often buy together, right? So that can really help so it can even shape your marketing strategy. So talking about core metrics now, you have support. So how frequently an item set occurs in all transactions. Of course, we've seen that in the last video. So that's support A equals P of A. Then confidence, how often B is purchased when an item A is purchased. So confidence A given B, that's A intersection B over P of A. P of A intersection B over P of A. I think in the last video we had A union B, should be A intersection B, sorry. So then we have lift. How much more likely A and B occur together than expected if they were independent? So lift A to B, it means confidence A to B all over support B. So you see that confidence depends on support, and support depends on, and lift depends on both confidence and support. So we have end-to-end Python implementation now. So below is a unified Python script with data preparation, frequent item set mining, association rule generation, visualizations for intuitive understanding. So let's see, install required packages. So again, of course, pandas. We need pandas for some for data frames and data manipulation, data cleaning, and things like that, if necessary. ML extend is particularly good for association rule learning. Matplotlib, Seaborn for showing up. For data visualization, and Network X is also for visualization, right? Because one way to visualize market basket analysis is through networks, right? So when I did network theory, I used Network X library in Python to do some network drawings. Okay, so the first thing is want to install required packages. I've installed all of them, so I'm just doing it uh, for Learning purposes. So this is fast, but if you are doing it for the first time, it may take a bit more time than this. So just patiently wait and have it have it run. So 4.2, you have load and prepare data. So import pandas as PDF. I think we've done this before. Then from ML extended preprocessing, import transaction encoder. We always need a transaction encoder in this case, just like we had for a priori algorithm. So here now you have the data set bread, milk, bread, diaper, beer, eggs, milk, diaper, beer, coke, and things like that. So then you have the one hot encode the transaction. So so you are importing, you are bringing in the transaction encoder with that name. Okay, I think it's always good to have line numbers for easy referencing. Okay, so we encode now. So TERA now. So transaction encoder, you have te.fit dataset, then the transform dataset, then DF, you have PD.data frame, TERA columns and columns like that. And that by the time that's done, you have, it shows you in each transaction which items were bought, which items were not bought. All right. So if you have your own data, you're definitely going to get result complete, like that is in line with the kind of transactions carried out in your supermarket, in your shopping mall, or whatever. Then the next thing is find frequent item sets. Find frequent item sets. So here now, from ML extend of frequent patterns, import a priori. So you see a priori is coming into this because we can't do market basket analysis without the a priori algorithm. Okay, so that's what this is about. So your frequent item set is a priori. The data frame is generated up there. The minimum support is zero point 0.6. You can increase it if you want more. You can reduce the minimum support if you want more items to show up. So here, use column names true, and then frequent item sets. Now, so if you run this, so based on that's zero point 0.6, we have these 7 items. Okay. Then if you want more things to show up, whatever. So if you make it like zero point 0.4, you have so much more. You have up to 16 sets coming. If you want it to be fewer, maybe you can make it like zero point 0.8, so you have just three in this case. All right. So I think zero point 0.6 is just fine like that. So with this now, we have the frequent item sets that go together. So the strongest of them being bread alone, diaper alone, or milk alone. But if you're talking about tools, beer and diaper, bread and milk and diaper always go together. So talking about um generate association rules. So from ML extend of frequent patterns, import association rules. So you have rules, association rules, frequent item set, metric is confidence, minimum threshold is zero point 0.7 for the confidence, right? Then the rules. So you want to have the antecedent, the consequent, the support, the confidence, and lifts, and then print association rules now, going by the rules. So you have all this, right? So so you can trim down this further by saying, okay, once you buy beer, the next most likely thing you're going to buy is diaper. And once you buy diaper, the next most likely thing you want to buy is beer. Once you buy bread, the next most likely thing you want to buy is diaper. Once you buy diaper, the next most likely to buy is bread, and so on and so forth. With all this support and confidence and all of these things. So, I mean, you can, if you take, since everything is zero point 0.6, and the confidence is almost always 0.75. So the most likely combination here will be bear and diaper with support zero point 0.6, confidence 1.0, and lift greater than 1, right? We know that lift less than 1 means negative association, that they don't ever go together. But lift equals 1 means they don't have anything in common. But lift greater than 1 means, that's the best deal. So the top two will be bear and diaper. Oh, bear and diaper, bear. Okay, it's just the same thing. So I mean, that's a decisive thing that it's bear and diaper that always go together almost all, in fact, every time. So the next thing is we want to visualize the results. So visualizations make patterns more insightful. Okay, so you can have heat map of support. You want to draw the heat map of the support. So here, import Seaborn as SNS and import matplotlib.pyplot as PLT. There's no heat map in matplotlib. That's why we need Seaborn, right? The two of them are for visualizing data. And in Python, matplotlib is the most important visualization tool library, right? But if you want something more, like you want some statistical intervals and things like that, Seaborn comes into it. And things like heat map, you can only find in Seaborn. Then if you want to take things further, you can go Plotly and all that. So focus on simple pairs now. So if you just want simple pairs, so we have pair rules. So we have rules. So rules antecedent apply lambda X length is X. So we just want when the length is just one, then the consequent is just one. So we are focusing on simple pairs. Then you can build a matrix for heat map. So heat map data is now the pair rules now that you've put here, the pivot table and all that. Then we can see this on a heat map like that. So it's still on, so now it's fine. So of course you see 0.6 beer, diaper, beer, bread, milk, and so on. So 0.6 is about the strongest for the we are talking about confidence, right? For support, right? 0.6. So everything lies with this median level. So antecedents and consequence like this. Then you can also do the scatter plot of support versus confidence, right? So scatter plot rules support, rules confidence, and then see rules lift, and then you can have a color something to it, a color differentiation. So you have this now. So you have this yellow up here, and then you have the support down here. So I mean, it's quite. So the color is about the lift, right? So this is a more most likely thing, and I think that's a beer and bread situation or is it beer and diaper now? I think it's that beer and diaper, yes. You know. So you can also do a kind of network thing. So network graph for items and rules. So you can import network X at as NX, then G is diagraph. So that's bi-directional arrow graph. Then you now say for this row in pair rules, then you iterate the row. So the antecedent, list row antecedent starting from zero, from con. So list row consequence zero like that. So you have G dot add edge antecedent consequent weight is zero, then the lift, then plot figure size 8 by 6, and POS and position now. So I'm talking about position. You do all this, and then it shows us, the whole how things go. So you see now that after milk, the next most likely thing to buy would be either bread or diaper with the same level of with the same 0.94. But after diaper or beer, so it's stronger that after diaper you buy beer than anything else. Or after beer you buy diaper. Okay. So but after you buy diaper, there's the chance of buying either milk or bread is the same like that. So but the strongest association is between diaper and beer. So that may make you curious, like why is that happening? Why is somebody taking care of kids also buying beer, right? So I mean, those things you can dig deeper to find whatever that might bring up. So interpretation tips now. High support means popular combinations. Like we see that diaper and beer is a very popular combination. High confidence means strongly reliable rules, and lift greater than one means real associations more than random chance. So in summary, market basket analysis helps discover item co-occurrence patterns, and the key metrics are support, confidence, and lift. And these are basically probabilities. Then you have the visualizations. It can be in form of heat maps, scatter plots, or networks. And this makes they make patterns actionable. So you can actually scale it to large data sets, e.g., online retail logs, or integrate into a recommendation engine and experience with different thresholds. But of course, just like a Apriori algorithm, you can also almost you can always already imagine that market basket analysis may also be very difficult. If you are working with very large data sets. And that is why in the next video, we'll be considering the frequent path growth algorithms, FP growth algorithms. So, all right. So this brings us to to the end of this video. Feel free to let me know how helpful this is for you. And if there's something you'd like me to do after now, feel free to let me know also. If you have subscribed already, thank you so much. If you have not, of course, you don't want to miss the great content I have going on here. So you definitely want to do that right now. So, subscribe and hit the notification bell so you can always get alerted each time a new video is released. My code sheets and data sets are available. If you check the description box, it will take you to a Google Drive where you can download everything. And as I teach, you can follow step by step. And because the best way to code is to code. If you watch video and you're unable to implement, that's a problem. So I always advise download all the code sheets, and as I begin to explain, so you can pause the video, try it out. If you get it, move on, and that way you can really commit to memory what's really happening in this whole process, right? So Also on my channel, you can be a member. There are layers of membership for different levels of benefits. So you want to check that out and become a member today. Till I come your way again, keep doing data right. Of course, don't forget to like and share. Right? Bye.